Let's calculate some probabilities here based upon information that's given. We're told that 72% of girls are fans of Disney princesses. So if we randomly survey 18 girls of this age, what is the probability that exactly 14 of these 18 say yes to this survey? Each time we survey one of these girls, there's a 72% chance that they're going to say yes. So that is your probability, P. Right? So the probability that a girl is going to say no is equal to 1 minus 0.72 or 0.28. This is a binomial probability because there is only two outcomes for each trial. Right? Each trial has either a yes or no answer. Since there are 18 girls being surveyed, that means n is equal to 18. And what part A is asking us is the probability that x is equal to 14. That means 14 successful trials. In your calculator, the menu item binom PDF in the distribution menu is going to help us calculate this binomial probability. The inputs are n, the number of trials, then P, the probability of success, and then X, the number of trials that we deem to be successful. So we'll hit second and then vars. We'll move all the way down to menu item A, binom PDF, and we'll put in these values. N is going to be equal to 18, comma. P is going to be equal to 0.72, comma. And then X is going to be equal to 14. Hit enter, and here is our value, 0.189. Right, so I'll write this down, which is that N is going to equal 18 here, P is going to be 0.72, and then X is going to be 14. Excuse me. So what if it asks for the probability that at least 9 are fans? This is different than finding exact, right? The main difference is that now there are multiple values of X that this at least 9 covers, right? When we calculate, X can be 0, 1, 2, 3, 4, all the way up to 8, 9, 10, all the way up to 18, right? These are the values, these are the number of successful trials that we can have, anywhere from 0 up to 18 successful trials. So the probability that X is greater than or equal to 9 really indicates this block of X values right here, which means we have to find the probability X equals 9, then the probability X equals 10, then the probability that X is equal to 11, all the way up to the probability X is equal to 17, and then the probability X is equal to 18. And what we have to do with all of these individual probabilities is add them together, which means we will be calculating this binomial probability about 10 times. Not ideal. Instead, what we're going to do, because this is the probability distribution, right? X can take on all of these different values. That means the sum of all of these probabilities, equals 1. So if we're able to find the opposite, where X is less than or equal to 8, right? This over here should say less than or equal to 8. If we can find, and the sum of all of these probabilities where x is less than or equal to 8, that means we can subtract it from 1 in order to get our answer. And thankfully, our calculator has what's called a binomial CDF function, cumulative distribution function, which does exactly that. The inputs are the same: n, the number of trials, p, the probability of success for each individual trial, and then x, the number of successful trials. But what the CDF function does is it finds the probability that x is equal to 8, plus the probability x is equal to 7, plus the probability x is equal to 6, plus the probability x is equal to 1, plus the probability x is equal to 0. It adds up all of these probabilities for us. So let's take a look at that, right? When we hit second to get to the distribution menu, choice A was binomial PDF, choice B is binomial CDF. And again, we're going to input the same values as we did before for n, and then the probability of success for each individual trial, again, same as before. We're going to input 8, which again, because this is now binomial CDF, the 8 means something different. And this says a 0.013% chance. Again, that is all of the values of x from 0 to 8 added together. The probability x is 0, all the way up to probability x is equal to 8, added together to get this number. So 1 minus 0.013 is 0.987.